Hello viewer, welcome to Kenya Secondary School Chemistry lesson, and specifically we are going to feature the Form 4 lesson basing on the problem that we are facing currently in our country of the major pandemic called coronavirus. And we have decided that learning cannot be stopped. We can continue learning while embracing technology. So therefore, today we are going to start learning chemistry, and your presenter is Hilary Kikoskei. You can also find me through our YouTube channel at Mwalimu Hilary Mwalimu Sitonic. Mwalimu Sitonic is our YouTube channel that we are going to be running these lessons. So please, if you want to watch more, subscribe for you to actually get the lessons. And today we want to actually go further and see a topic in Form 4. Basically, this is a topic which has been tested in the Kenya KCSE for over 10 years. It has been tested frequently, and therefore we want to make our learners to be able to actually tackle this topic adequately. And in so doing, we actually want to start our presentation. We are going to present this topic from the start until the end. And therefore, to start this, we are going to look at the objectives of this lesson, in which, by the end of this lesson, the learner should be able to, number one is describe redox reactions in terms of the gain or loss of electrons. Number two, we also want to, the learner should be able to identify the oxidizing and the reducing agent involved in the redox reaction. Redox reaction is actually the reduction and oxidation which is taking place at the same time. Now, let's go straight away to this topic called electrochemistry. What do you understand by this term, electrochemistry? Electrochemistry can be defined as the study of effect of electricity on a substance. Now, the first part of this definition was actually captured in the Form 2 on a topic called the effect of an electric current on a substance. Now, whereby we were looking at how a substance, how electricity affect a substance. And for instance, we have let's look at, for example, lead iodide, lead 2 iodide. Lead 2 iodide, when you actually hit lead 2 iodide, and then you actually connect the electricity through the solution. After some time, the current will flow, since now the ions are mobile, and therefore it can actually complete the circuit. Now, and in Form 4, we are going to deal with the second part, which actually we are saying how chemical reaction produce electricity. In this, we are producing electricity, and in the other one, electricity was used to affect a substance. Now, electrochemistry will deal with the following parts. Number one, we have what we call the reduction and oxidation. That is the first one. That is the first part that we are going to deal with. Number two, we are going to deal with electrochemical cell or voltaic cell. Now, the last part of electrochemistry in Form 4 is actually electrolysis or electrolytic cell. Electrolytic cell. And therefore, lastly, we are going to see the applications. Majorly, it is actually the application of the three of them. So these are the major parts of electrochemistry in the topic in Form 4. Now, maybe we can start looking at the first part of it. Let's start by looking at that. Now, let's begin by these terms, defining these terms, so that we actually become familiar. Now, you will understand that we have the following terms. Now, we have oxidation and we have reduction. These terms are not new terms to you. Fewer, as you have come through Form 1, Form 2, Form 3, and Form 4. Now, I hope you made this in Form 1. Oxidation is a term you made in Form 1. Reduction is a term you made in Form 1. But in Form 1, you are saying that oxidation is actually addition of oxygen to a substance. And the reduction is actually removal of oxygen from a substance. That is actually what you are saying in Form 1. But this one, today, we want to define these two terms in terms of electron. How is electron defined? How is electron affecting the definition of this? We are saying electron can be gain or loss. Now, let's look at oxidation. Oxidation is actually a loss of electrons. Oxidation is actually the loss of electrons. Now we come to reduction. Reduction is actually the gain of electrons. The gain of electrons. So, when we combine the two words, it gives us a word like this, redox. Redox is an abbreviation of reduction and oxidation. So this basically is a simultaneous gain and loss of electron. Now, let's also look at this. Now that we have seen oxidation and reduction, let's look at this term called reducing agent. What is actually reducing agent? Reducing agent is the species that undergoes oxidation. It is the species that undergoes oxidation. And as you have known that, oxidation is actually the loss of electron. Therefore, reducing agent is the species that loses the electrons. I hope you are now getting what we have said. And therefore, on the other hand, oxidizing agent is the species that undergoes reduction, and therefore it gains electrons. Now, hope now you have these four terms. That oxidation is the loss of electrons. Reduction is the gain of electrons. Redox is the simultaneous gain and loss of electrons. And therefore, we are saying that a reducing agent is a species that undergoes oxidation, and therefore it actually loses electrons. Now, the oxidizing agent, as we have said, is the species that undergoes reduction and therefore gains the electrons. Now, let's go further and see an example of this so that we can understand more about oxidation, reduction, reducing agent, oxidizing agent. So, in this, we are going to see an experiment on displacement of metals from their solution. Now, how are we going to achieve this? First, you actually measure 5 cubic centimeters of 2 molar copper 2 sulfate solution into 3 different test tubes. Now, number 1, then you add what? You add 0.5 grams of zinc powder into the test tube. Shake thoroughly for around 2 minutes. Then record any color change in the table below. You will find that when the zinc is added, the blue color of the solution, which is now copper 2 sulfate, start to fade away. It's fade away. So that means the blue color disappears. And what is the resulting solution? The resulting solution there is actually colorless. The solution now is rendered colorless. So it's actually, basically, it is evident that there is actually a change in chemical reaction because it changes from blue to colorless. Now, at the same time, you will find that we will have a deposit of a brown substance. a brown substance is deposited. A brown substance is deposited. What is when you see this brown substance? What do you understand by brown substance in terms of metal? We know that a brown substance is actually as a result of copper. So therefore, that means copper is coming out of the solution, and zinc is actually disappearing and going into the solution. What has really happened there? So we are going to look at what is happening there, because this is actually a chemical change. Now, this chemical change will result in the following. Let us try to explain this. Now, we are saying when a more reactive metal is added to a solution of less reactive metal, it displaces it from its solution. Now, I hope you still remember what you learned in Form 1, that we have substances, or we have metals which are more reactive, and we have those which are less reactive. Now, when we visit reactivity series in Form 1, I hope you have your notes and you can visit that now. So when you visit that, you will find that zinc is more reactive than copper, and therefore it is actually evident that copper can be displaced by zinc because it is more reactive. And when this happens, we are saying when a less reactive metal is added to a solution of more reactive metal, it does not displace it from a solution. So this one, basically we are saying, if we have a solution of a more reactive metal and we have a metal of a less reactive metal, we are saying there will be no reaction. Why? Because there will be no displacement. There will be no displacement. And therefore, it causes us actually to look at what is happening here. So we are saying zinc is more reactive than copper, therefore can displace copper from its solution. Now, a brown substance is copper metal displaced from a solution of its ion. So we have seen that actually zinc can displace copper from its own ions. Now, let's go ahead in terms of electron transfer. We want to explain this in terms of electron transfer. We are saying the more reactive metal undergoes oxidation. And what is the meaning of this? The meaning of this is that it loses electrons. Now, when it loses electrons, you know, in every other metal, or every other substance, or every other element, now we have the atom containing the same number of electrons and protons. Now, and in chemical reaction, we are saying it involves electron gain or loss. So therefore, this one is actually losing the electrons. What is the meaning of that? If we had the same number of electrons and protons, that means that the protons which are positively charged will be more, and therefore we are saying it undergoes actually oxidation, because you will learn later on that the oxidation number of an atom is actually 0, and therefore we will have an increment of actually the oxidation number. Now, the less reactive metal undergoes reduction. Why? Because now in its solution it is an ion. It's an ion, and therefore the ion now will actually go out. It becomes now an atom. Okay? It becomes now an atom, and therefore we'll have now the oxidation number reducing. That is why we are saying it is oxidizing agent, because it is now accepting the electrons. It's accepting the electrons. It's accepting the electrons. Now, basically, this is what we have actually seen. Now, let's look at the third one, which is actually displacement. In terms of displacement, displacement of metals involve therefore electron transfer from a more reactive metal to ions of another less reactive metal. So we are saying now electrons are transferred where? To from a metal which is more reactive to a metal which is less reactive. So if you take an example of copper and zinc, zinc is a more reactive, so therefore it transfers electrons. It transfers electrons to copper, which is actually less reactive, and therefore copper was deficient of 2 electrons. Therefore, it gains those 2 electrons. Now let's look at this in terms of equation. Zinc is now losing the electrons to become zinc ion. So therefore, when it loses electrons, these are the two lost electrons. Copper will gain the lost electron, and therefore it renders copper to be a metal. Now, this is an overall equation of actually redox reaction, whereby we have here we have this one which is reducing from positive 2 to 0 there. Later on we are going to look at that properly, and we are going to understand that. But basically I want you to understand that this is actually in terms of loss and gain of electrons. It is actually in terms of loss and gain of electrons. Now let's look at this one in terms of energy. Now, whenever there is a chemical reaction, it is actually involving energy change. So we are saying in displacement reaction, it also produces energy. It also produces energy, and the production of energy depends on the position of a substance in reactivity series. Now, if the two of them are close, if the two of them are closer, if the two metals are closer, then we'll have the less energy. We'll have the less energy. Now, if we have the two metals, with actually a higher range. If we have another one higher and then we have another one lower, so there will be actually a wide range left, and therefore also it is proportional to the energy produced. The energy which is actually produced is actually higher. So therefore, it depends on now the range. It depends on the range where it is. If they are close, then the energy produced is small. Now, I hope this one was actually tested in the practical. I think in the year 2018, if I'm not wrong, in the year 2018, which they were asking. Now, suppose we have this method and we have this method. How will be the energy? How will be the energy? This is a question which was tested, and you have actually to understand this. That actually, depending on the closeness or actually the fartherness, the energy is proportional. Now, let's actually wind up this lesson by saying that by looking at this question. So I hope now you have your notebook, and you can be able to write this question. The question is: identify the reducing agent in reaction below. Identify the reducing agent in reaction below and give a reason for your answer. Now, what reason are you going to give? The reason that you are going to give is actually the one that we have learned. But I want you not to forget this. We have said that oxidation is actually the what? The gain, the loss of electrons. The oxidation is actually the loss of electrons, and reduction is actually the gain of electrons. And we are saying now the oxidizing agent is the one which gains the electrons. It's the one which gains electrons. It's actually a species that gains the electrons, and reducing agent is the species that loses the electrons. And therefore, the reducing agent is the one now which is more reactive, and the oxidizing agent is the one which is less reactive because it is gaining electrons. The other one is giving out electrons. Which one is giving out electrons? It is actually the one which is giving out the electron is the reducing agent. So I think we have so far covered that. We have seen how that is affected in a reaction. So therefore, that is for that today. But don't forget to subscribe this to get more lesson. When a lesson is posted on the YouTube, you will actually be able to actually be notified when we have a new lesson. So the channel is Mwalimu Sintonic. Mwalimu Sintonic is actually our channel that we are using to post chemistry lesson for now, and maybe others are coming next. So thank you very much for following us in this lesson. Next time we are going to look at another lesson in this topic called electrochemistry. Thank you very much. May God bless you.